So after you've watched the titration that I did with the vinegar, we can start recording our results. So I know that I used 10 milliliters of vinegar, and my pipette was precise to the first decimal place. So I can write 10.0 milliliters. And if you were paying attention, you would have noticed the concentration of sodium hydroxide on its label was 1 mole per liter. So we have that. Now the initial burette reading was 4.70 milliliters. Once I reached the end point, the final burette reading was 13.69 milliliters. So if you do the math, you just subtract initial burette reading from the final burette reading, and it ends up being 8.99 milliliters. So that is the volume of sodium hydroxide that I added to my vinegar. Now I mentioned in the titration that normally you would do this for a few trials to make sure that you have a consistent result. So I'm just going to make up some values for a second and third trial. So let's say the second time I did this, I used a little bit more sodium hydroxide. So let's just say I used 9.05 milliliters. And the third time I did it, I used a little bit less. Let's say I used 8.85 milliliters. So once you've done 3 trials and you've got consistent results, so they're all within about 0.1 or 0.2 milliliters of each other, then you figure out the average of those 3 trials. So just recall, to find an average of 3 numbers, you add up the numbers, get your sum, and divide that by 3 in this case, because we have 3 numbers. So on average, I used 8.96 milliliters of sodium hydroxide in my titration of the vinegar. And this is where it gets fun. This is where we get into the actual calculations here. I start by setting up my stoichiometry grid. Now you'll notice I just kind of left off the products. I don't really care about the products for this calculation because I know how much sodium hydroxide I used, and I want to figure out the amount of acetic acid. So I'm just not going to write the products in this. But still, I fill in what I know. So I know that I used 10 milliliters of acetic acid, my vinegar. I know that I added, on average, 8.96 milliliters of sodium hydroxide. And I also know that the concentration of sodium hydroxide was 1 mole per liter. So I know all these things. Now I need to calculate the number of moles of sodium hydroxide that I added. Remember, N is equal to C times V. So that means I added 0.00896 moles of sodium hydroxide. Remember, we reached the end point of the titration, which means neutralization. That means the number of moles of H plus ions is equal to the number of moles of OH minus ions. So we use our 1-to-1 ratio. The number of moles of acetic acid is the same as the number of moles of sodium hydroxide. Like so. Now I can calculate what the concentration was for my acetic acid. Number of moles divided by volume, which is 0.896 moles per liter. So that's my answer. That's the concentration of acetic acid in my vinegar. But the label said 5%, so I want to see if that percentage is correct. So what I need to do is figure out what is the mass of acetic acid in that sample, And I'm going to use that to figure out what percent of my vinegar was acetic acid. So I use my periodic table to find the molar mass of acetic acid. 2 carbons, 4 hydrogens, 2 oxygens gets me 60.06 grams per mole. To calculate mass, it's number of moles multiplied by molar mass, which means in my 10 milliliters of vinegar, there were 0.538 grams of acetic acid. Now I can use this to calculate my concentration. Expressed as a percent, I'm going to have the mass of acetic acid on the top and the mass of my solution on the bottom. So I know the mass of my acetic acid was 0.538 grams, but what's the mass of my solution? Well, I know I used 10 milliliters of vinegar, and aqueous solutions, you can use roughly 1 milliliter is 1 gram. So if I used 10 milliliters, that means 10 grams. So I'm going to take 0.538 divided by 10, which gives me a decimal, and then I can change that into a percent. So it looks like the concentration of my vinegar was 5.38%. And if you'll recall, that's kind of what the label said. It said it was 5% acetic acid. So we're really close.